Okay, welcome back. What is the answer for this question? Any answer? Option A. Very good, very good, very good. Very good. Yes, let us see this question. 2-point charges. Let us have some rough diagram for this one. Where two charges are located? Charge Q1 is located at 3, 0, 0. Charge Q2 is located at 1, 2, 0. Charge Q0 is located at 1, -1, 0. What is the force on this due to this one? What is the force direction? Line joining 2 points. Here it is the F1. What is the force on this one? It is F2. What is the total force? F total? F1 plus F2. In that total force, read the question carefully. In that total force, X component is equal to Y component. If that is the case, he is asking the relation between Q1 and Q2. Yes. So how do you find out the force between two charges? F is equal to Q1 into Q2 divided by 4 pi epsilon vector by its magnitude cube. Let me turn the page here. What is the total force beta? F1 plus F2. What is the F1? Q1 into Q0. Q1 into Q0 by 4 pi epsilon vector by its magnitude cube. What is the vector beta? I want to find out the force on Q0. This one due to this one. So here it is 1 minus 3. 1 minus 3, here it is minus 2 x cap. Minus 1 minus 0, here it is minus y cap divided by square root of 4 plus 1 whole cube plus Q2 into Q0 divided by 4 pi epsilon. 1, this point minus this point. 1 minus 1 is 0. Minus 1 minus 2, it is minus 3. Minus 3 y cap divided by its magnitude is 3 cube. Let me write one more step beta. F total is equal to Q1 into Q0 divided by 4 pi epsilon minus 2x cap minus y cap divided by 5 root 5 plus Q2 into Q0 divided by 4 pi epsilon minus y cap by 9. Here this is the x component beta. This is the y component beta. So what is given? Given x component is equal to y component. So equate. Let me bring the x component on one side. Q1 into Q naught divided by 4 pi epsilon minus 2 by 5 root 5, which is equal to y component. What is the y component? Q1 into Q naught divided by 4 pi epsilon minus 1 divided by 5 root 5 plus Q2 into Q naught divided by 4 pi epsilon minus 1 by 9. Just cancel out this one. Here it will become plus, plus, plus. Here Q naught by 4 pi epsilon naught. This is a common thing. Just cancel out on both sides. Here it is 2Q1 divided by 5 root 5. Q1 divided by 5 root 5 plus Q2 divided by 9. Here it is Q1 divided by 5 root 5, which is equal to Q2 by 9. Q1 by Q2 is equal to 5 root 5 by 9. Yes. Let me go back here. So what is this one? Q1 by Q2 is equal to option A is the answer. Clear, beta? Let us take one more question. I'm going to turn the page. Let us take one more question, beta. A charge Q is divided between 2 point charges, comma, what should be the values of this charge on the objects so that the force between them is maximum. Option A, Q by 3. Option B, Q minus 2. Option C, Q by 2. Option D, two Q. Yes, what is the answer? Yes, what is the answer? It is See here, there is a charge q is divided between 2 point charges. Here is a charge q is divided between two charges. Let us say here it is a q1, q2, where q1 plus q2 is equal to q, and the distance between these two is, let us say, r. What is the question here? What should be the values of charge on these objects so that the force between them is maximum? So you need to distribute the charge on them so that the force between them must be uniform. Sorry, maximum. What is the force between two charges, beta? F is equal to, I'll take only the magnitude, q2, q1, q2 by 4 pi epsilon r square. So here there is a relation. Q1 into what is this q2? Q minus q1 divided by 4 pi epsilon square. So here it is q1 into q minus q1 square divided by 4 pi epsilon r square. Yes, so you need to distribute the charges so that the force between them is maximum. Means what? I'll vary. I'll use this technique. I'll find the condition for maxima. I'll going to differentiate this one with respect to q1. 1 by 4 pi epsilon r square is a constant. I'm changing only the charge q1. So here it is q minus 2q1. For the maxima, what you'll do? You'll make that one equal to 0. So here it is q minus 2q1 is equal to 0. q1 is equal to q by 2. So I need to distribute charges equally so that the force between them will be maximum. Yes. So what is the answer here? Option C is the answer. I'll take one more question, beta. Yes, very good. I'm going to turn the page. Let us have one more question. Two positive charges q and 2q, sorry, 2 and 4q are separated by a distance d. In the air, a third charge is so placed. Third charge is so placed that the entire system is in equilibrium. Determine the location, comma, the magnitude determine the location, the magnitude, and the sign of the third charge. Yes, what is the answer? See here, I am using something word equilibrium. Two charges Q and plus 4Q are separated by the distance D in the air. A third charge is so placed that entire system is in equilibrium. Determine the location, comma, the magnitude and the sign of the third charge. Here is a thing. Two charges are there here. There is a charge Q and there is other charge 4Q. These are separated by the distance D. So I want to bring the third charge here into the system so that the entire charges will become into the equilibrium. Equilibrium means what? The net charge in the system is 0. If you find out the total charge, total force on any charge, that will be equal to 0. So where should I bring the third charge? Should I bring in between, I mean, between the two charges, or my charge should be here or somewhere here outside? Between or outside? Let at least give me this answer. Between them or outside? Yes, some of your friends are even answered that. Very good. Between the third charge should be somewhere here, so that the force from here and force from here he will going to meet there and the cancellation happens. The third charge will be, is it towards the Q or is it towards the 4Q? The third charge should be towards the Q. Why? Because the force from here to here, it will weaken. Anyhow, the charge Q is having a weak force. So there is a possibility for the cancellation. Anyhow, we're going to get the distance here. Here is a X. This is a number 1. Here it is a number 2. Here it is number 3. So the system will become an equilibrium when the force between the two charges is equal. If you take the force between these two is equal to force between these two is also equal to force between these two. If you take any charges, the force between them will be equal to the force between other things. Then only the system will be in the equilibrium. So what happens for equilibrium? For equilibrium, F12 magnitude is equal to F23 magnitude is equal to F31. So what are you going to get? Just magnitude Q into Q by 4 pi epsilon x square is equal to Q into 4Q divided by 4 pi epsilon d minus x square, which is equal to Q into 4Q divided by 4 pi epsilon d square. So here it is. I can write in one more step. So here it is Q by x square, which is equal to, no, keep as it is. What I'll do, first I'll equate these two things. Next I'll equate these two things. First, if I equate those two things, what I'll going to get beta? 1 by x square is equal to 4 divided by d minus x square. Let us take the cross product here. I'm going to turn the page. What I'm going to get from the cross product? D minus x square is equal to 4 into x square. So here it is d square plus x square minus 2dx is equal to 4x square beta. So you want x. So here it is 3x square minus plus 2dx minus d square is equal to 0. So what is this x? X is equal to minus b plus or minus b square minus 4ac by 2a. B square is 4d square plus 4 into 3 into d square divided by 4 minus b plus or minus square root of b square minus 4ac by 2a. So here it is 2 into 3. So x is equal to minus 2d plus or minus square root of 16d square by 6 beta. Minus d plus or minus 2d divided by 3. Clear? So there are two things you will going to get here. Minus 3 by 3 is minus d. Here it is d by 3. Somewhere I have done mistake. D by 3 from Q. Yes. It is d by 3. So what is the valid answer here? D by 3 is a valid one. Okay, so it must be d by 3 from the q charge. Then let us consider the remaining part for the charge value q. I'll equate these two things. What it is? Q into q divided by 4 pi epsilon x square is equal to q into 4q divided by 4 pi epsilon d square. So here it is q by x square plus 4q by d square. So here charge is equal to 4q by d square into x square. X square value is 4q divided by d square into x value is d by 2. So here it is 4q by 9 is the answer. But what must be the sign of the charge q beta? Sign of the charge q must be negative charge, isn't it? So the actual charge, this is only the magnitude. The actual sign of the charge q must be negative. Then only the force will come from here to here. Force will come from here to here. They will meet and they will cancel out. Yes or not? So the actual sign of the charge is, charge q is the actual sign of charge q is minus 4q by 9 beta coulombs. Clear? Yes. Fine. So this is all about electric force. Some of the questions which are related to the electric force. Now let us focus on what is called electric field is. Because electromagnetic field theory it is. Let us try to understand what actually the field is. I'm going to turn the page here. I'm going to introduce some new vector, what is called electric field intensity. Electric field intensity, or simply it is called electric field beta. It is represented with the E. Units are Newton per coulomb. The other units are volt per meter. We'll discuss later that one. See here, we are assuming that charges are collinear. They are on the straight line. This charge you can place anywhere, here also. Isn't it? Fine. Let us focus on this one, electric field intensity or simply electric field. Let us consider the charge Q beta. And let us consider some other charge Q. The distance between these two things is R, and the unit vector is R cap. And here is a force F. This charge Q is called field producing charge. This charge Q is called test charge. What does that mean? I'll explain. So what is the force between these two things? F is equal to Q into Q divided by 4 pi epsilon R square R cap. I'll bring that charge Q here. F divided by Q is equal to Q by 4 pi epsilon. This is called force experienced per the unit charge is called electric field. Okay, what are the units for this one? Newton per coulomb. So the F is equal to Q into E. Yes. See here, mathematically speaking, the force experienced for the unit charge, is the electric field. But let us try to have some physical interpretation of this one. I'm going to turn the page here. What is the electric field E? E is equal to Q by 4 pi epsilon R square into R cap. This is the electric field. How the electric field is? Electric field is radially outwards from the charge. Yes. Let us consider the charge Q beta here. So from that, it is a spherical coordinate system. From that, we can say that the electric field is radially outwards. Here is a charge Q beta. So the electric field is radially outwards if it is positively charged. If it is negatively charged, radially inside beta. Suppose let us say I want to find at a certain point here at a distance of d1. What is the electric field at a distance of d1? E1 is equal to q by 4 pi epsilon d1 square into d1 cap. But what is the force here? Force is not defined there. Why? Because if you want to have a force, what is the force beta? F. F is equal to q into E. If you want to have a force, there must be a charge. So there is no charge here. Only there will be electric field. Now let us consider at a point D2. So what is the electric field? E2 is equal to q by 4 pi epsilon D2 square into D2 cap. What is the force is not defined because there is no charge here. Suppose let us consider at some other point at a distance of D3. What is the E3? Here I have placed some charge Q. So what is the E3? E3 is equal to Q by 4 pi epsilon D3 square into D3 cap. But what is the force F3? F3 is equal to Q into E3. So the electric field is surrounded, it is the imaginary quantity. Try to understand, if there is a charge, the electric field is present everywhere. It is the imaginary quantity. What we can experience is only the force. But why you are intentionally introducing this electric field concept? Because it will give the complete picture of the physical quantity which is existing around the charge here, everywhere. It is something like if you consider the earth surface. Around the earth surface, what is there, beta? Around the earth surface, everywhere there is a gravitational field is there. We cannot experience the gravitational field because it is the imaginary quantity. How you can experience that gravitational field? By putting some mass here. If I am putting some mass, that field will turn into force. So from now onwards, we'll be talking only in terms of field. Why? Because field will give the complete picture. Field will give a complete picture. But ultimately, what you must remember is, whenever you want to experience that, you have to place some charge. But mathematically speaking, there is no much difference between field and force. Just you need to assume that as if there is a unit charge. Clear, beta? Yes. So that is the reason why what I have written here, charge Q is a field producing charge. Charge Q is there. It is creating the field around this one. And if you want to experience that one, you need to place some test charge. Clear? So this is the interpretation of the field, beta. But let us take one question here. There is no much difference between the field and force mathematically. But let us have one question here. I'm going to turn the page. A positive charge Q coulombs is located at point 0, 0, 3 and negative charge of minus q coulombs is located at point 0, 0, minus 3. The resultant electric field acting at point 4, 0, 0 is in option A, negative x direction, option B, negative z direction, option C, positive x direction, option D, positive x z direction. Yes, what is the answer, beta? Come on, speak out. Very good. Yes. Electric field intensity, resultant electric field acting at point acting at a point 4, 0, 0 is in. Yes, you can directly decide this one. Directly in the sense, you can do something. See here. There is a charge here. Charge Q is located at 0, 0, 3 and minus charge Q is located at 0, 0, minus 3. There is a one more charge. Where he is asking at 4, 0, 0. What is the electric field due to this one? I'll call it as a E plus. What is the electric field here, beta, due to that one? I'll call it as a E minus. Whenever the negative charge is given, sorry, the electric field is towards the negative charge, isn't it? So what is the direction here? Towards this one. When you take the direction towards the charge, already as you have taken the direction, you need to discard the negative sign. And you need to do this point minus this point. This is a precaution need to be taken. But to avoid the confusion, whenever the negative charge is given, put this one in the bracket. Consider the charge along with the negative sign. So here is the electric field. E minus. So you can perform this point minus this point. Along with the negative sign. So what is E total, beta? E plus plus E minus. So what is the electric field here? Electric field here is equal to E is equal to Q by 4 pi epsilon R square into R cap, or E is equal to Q by 4 pi epsilon vector by its magnitude Q beta. Let me turn the page here. So what is the charge? What is the electric field here? E total is equal to Q by 4 pi epsilon. This point minus this point beta. It is 4x cap 0 minus 0. Here it is minus 3z cap divided by square root of 16 plus 9 whole cube plus consider the charge along with the negative sign 4 pi epsilon. This point minus this point. So here it is 4x cap. Here it is plus 3z cap divided by square root of 16 plus 9 whole cube. Yes, you can directly take this one common. Q by 4 pi epsilon divided by 5 cube. 4x cap minus 3z cap minus 4x cap minus 3z cap. So which is Q by 4 pi epsilon 125 into minus 6z cap, or 6q divided by 4 pi epsilon 125 minus z cap. So which directed is this? Resultant is in the minus z direction. Clear beta? Okay, fine. Like this, the electric force problem and electric field problem are same. When you are dealing with electric field, you need to assume as if there is a unit charge and you need to proceed. Clear? Yes, fine. Let us try to have, so far we have solved the questions by taking the point charge, isn't it? But the charge distribution may happen over the different dimensions. Let us try to understand what are the different types of charge distributions. Types of charge distributions. And electric field expression. And electric field expression. Okay, fine. Now let us have different types of charge distributions. Yes, the first one is a discrete charge beta. Number one, discrete charge is also called point charge. That is what we have been dealing with. Yes, this is called a discrete charge, or it is also called point charge. It is represented with the Q coulombs. There is a charge here, Q1 here, Q2 here, Q3 here, Q4 here, so on. How do you find out the total charge beta? Just summation. Q1 plus Q2 plus Q3, so on, up to Qn. How do you find out the overall electric field E total? E total is equal to the summation you need to use. Summation of I is from 1 to n. Qi divided by 4 pi epsilon Ra magnitude square Ra cap. This one we already know. Okay, just you need to take the summation. Now let us focus on the next type of charge. I will going to turn the page. Charge distribution may happen over the line beta. Number 2. It is called line charge density or simply line charge. It is Royal. Units are coulomb per meter. Let us take Q is a total charge. Charge distribution may happen over the line beta. Something like this. Okay. Let me consider a small piece of a length here. What is the charge in this one? dq. And what is the length of this one? dl. Clear? Now I am going to introduce some new charge. I am going to define charge per unit length. How? Observe here. Rho L is equal to dq by dl. Units are coulomb per meter. Here dq is equal to Rho L into dl. If you want to get an overall charge, what you need to do? You need to perform line integral Rho L into dl beta. Clear? So you need to convince yourself in the help of in terms of units. Here it is coulomb per meter. Here it is per meter. Here it is coulombs. Now, how do you find out the electric field due to this one? I want to find out the electric field at a distance of r. What I will do, I will find out the electric field due to the small piece of length. That is, dE is equal to dq by four pi epsilon r square into r cap. If you want to get the overall electric field, what you need to do beta? And one more thing here. What is this dq? rho L into dl. 4 pi epsilon r square into r cap beta. This is the electric field due to the small piece of a length. If you want to get the overall electric field, you need to perform what is called a line integral. Rho L into dl divided by 4 pi epsilon r square into r cap. E is equal to, that's all it is. Here is the electric field. Line charge. Let me turn the page. Charge distribution may happen over the surface. Number 3. You can call this as a surface charge density, or simply you can call it as a surface charge. Clear? Yes. So you can call it as surface charge. It is represented with the rho s. Units are coulomb per meter square. Let us take Q is a total charge. The charge Q is distributed over the sheet beta. It is something like this. I consider the small piece of area here. Here it is dq and area is dA. I'm going to define some new charge. Rho s is equal to dq by dA. Units are coulomb per meter square. So here it is dq is equal to rho s into dA beta. For total charge, you need to perform surface integral of rho s into dA. Always you need to convince yourself with the help of units. What are the units for this one? Coulomb per meter square multiplied with the meter square. Here it is the coulombs. I want to find out what is the electric field at a distance of r. So how do you find out the electric field beta? I'll take the help of Coulomb's law. dE is equal to dq by 4 pi epsilon r square into r cap. So dE is equal to rho v into dV divided by 4 pi epsilon r square into r cap. What did I write? Rho s beta. Rho s into dA divided by 4 pi epsilon r square into r cap. So to get the overall electric field, I should perform surface integral of rho s into dA divided by 4 pi epsilon r square into r cap. Clear beta? Let us take the last charge, volume charge beta. I'm going to turn the page. Number 4 beta. Volume charge density, or simply you can call it as a volume charge. Here it is rho v. Units are coulomb per meter cube. Q is the total charge beta. Q is the total charge which is distributed in the volume. Something like this. It is something like a mango. Let me put some dots here to create the feel that it is a three-dimensional. Inside this one, there is a charges. Let me consider the small piece of a box here. The charge is dq and volume is dv. Here it is. I'm going to define the volume charge rho v. Rho v is equal to dq by dv. Units are coulomb per meter cube. So the dq is equal to rho v into dv. For total charge, you should perform the volume integral of rho v into dv. Always you can convince yourself with the help of units. It is coulomb per meter cube multiplied with the meter cube. Here it is coulombs. I want to find out what is the electric field due to this one at a distance of r beta. So what I need to do, same story. dE is equal to d cube by 4 pi epsilon r square into r cap. So here it is dE is equal to rho v into dv divided by 4 pi epsilon r square into r cap. So the electric field is equal to volume integral of rho v into dv divided by 4 pi epsilon r square into r cap. Is the electric field. Okay. So now let us take some varieties of questions on these charge distributions. Simple to remember. From the line charge, if you want to get a total charge, you should perform the line integral. From the volume surface charge, surface integral. From the volume charge, volume integral. I'll going to turn the page here. Yes. Let us have some question here. A sphere of radius 0.2 meters centered at the origin contains the electrical charge of density 2 by square root of x square plus y square coulomb per meter cube. Find total charge enclosed by the sphere. Yes, try this one. So what kind of charge he has provided? What kind of charge is that? You can confirm from the units, isn't it? You just said the electrical charge. Yes. So what kind of charge beta is this? Volume charge. So if you want to find out the total charge from the volume charge, what you need to do? You must perform what is called a integration. What kind of integration you must perform? You must perform volume integral, isn't it? Yes. How to approach for this one? Same story. What is the volume charge rho v? 2 by square root of x square plus y square. Units are coulomb per meter cube. And here, what are the limits here? The sphere limits are given. The radius is 0 to 0.2 meters. Theta is from 0 to 5. Phi is from 0 to 2 pi. How do you find out the total charge beta? Volume integral of rho v into dv. Right? But here limits are given that structure is a sphere. The best suited for the ease for our integration would be spherical coordinate system. So here you can also write what is this differential volume? R square sin theta dr d theta d phi. Here the volume charge is given in the Cartesian coordinate system. So you need to convert this one into the spherical coordinate system. How do you convert? We have or we know. In the today session itself, I have derived x is equal to r sin theta cos phi. Y is equal to r sin theta sin phi. What is this? X square plus y square is equal to r square theta into sin square theta. What is this? R sin theta beta is equal to square root of x square plus y square. So what is this rho v volume charge? Is equal to 2 by r sin theta. So what is the total charge beta? The total charge is volume integral of 2 by r sin theta into differential volume. What is the differential volume? R square sin theta dr d theta d phi. So here you can bring the 2 outside. Here it is r dr d theta d phi. Separate out the variables beta. R dr, here it is d theta, here it is d phi. Integrate. Substitute the limits. I'm going to turn the page here. So here it is 2 into r square by 2. Limits are from 0 to 0.2. Here it is theta. Limits are from 0 to pi. Here it is phi. Limits are from 0 to 2 pi. Upper limit minus lower limit. 0.2 square pi into 2 pi. 0.04 into pi square. Coulombs is the answer. Pi square is approximately 10. 10 into 0.04, it is 0.4, something like that. Give me the exact value. How much is this? Pi value anyhow approximated value. Pi into 0.04. 0.394 coulombs is the answer. Point 0.08. How? Let me go back. There is a 2 pi beta. Small correction here. Thank you. This is 8 beta. So here it is pi into 0.08. Here it is 0.789 coulombs. Clear? Let me turn the page here. We'll take one question here. I'll give it as a homework question. Given rho L is equal to 2x plus 3y minus 4z coulomb per meter. Find the charge on the line segment extending from 2, 1, 5 to 4, 3, 6. Okay, try this one better. Try this one. Now let me open the session for your doubts. Just raise your hands, I'll come to you. Pavan.
Sir, while calculating the R cap, we are subtracting R2 minus E2 minus E1, no sir. Why we should do like that, sir, in reverse?
This one, huh?
Yes, sir. In this case, why we are doing 4 minus 0? Why can't we do 0 minus 4?
0 minus 4 you can do, but you need to consider along with the negative sign. You have to discard the negative sign. If you already consider the direction, then you can you have to discard the negative sign.
Okay, sir.
Here I have treated this as a positive charge. So consider the negative sign in the here.
Okay, sir.
Yes.
Good evening, sir.
Yes, beta, boliye.
Sir, in the electric field intensity, where you draw the diagram, no, sir? Means, could you open that slide? Sir, in that, there is F1 is not exist, sir.
F1 does not exist here.
If
Because
you have negative charge, then only will exist.
if there is a charge, it will exist. If there is no charge, no electric field, no force.
Because at that time, my network is like that's why.
Hmm?
At that time when we were explaining this one, my network was in off, sir. That's why I did not get that point. Okay, sir. Thank you so much, sir.
You can measure.
Sir?
Engineers can experience only the force. Field is only on the paper. So we field analysis, but whenever you want to experience that, you have to place some charge.
Okay, sir.
Your circuits will respond to only to the force.
In between two charges, then exists a force.
Yes.
Hello. Good evening, sir. Good evening.
Good answers from your side.
Sir. Sir.
Lindu.
Sir, I think there is a conceptual mistake from in that F12 is equals to F21 is equals to F31 magnitude. We are taking in that problem. Here you said that Q will be negative. But Q may be positive also. For that, force will be opposite.
What will be?
That if Q will be positive, and also that force will be that Q and minus Q. Again, that will be in equilibrium. How to decide that?
They should not be collinear. They should not lie on the line.
If this will okay, this if it will be a positive charge.
If it is positive, somewhere it must be here between these two, somewhere here. So the force will be there. Resolve and cancellation may happen.
Sir, can we decide from here that from Q and for Q that you said that F31 magnitude will be equal. All three forces will be equal. Can from here we decide that Q and for Q they are opposite force, and that Q will be negative so that it will be attract.
Yes.
Okay. That concept can we decide somewhere?
Your voice is not clear. Breaking it is.
Okay, sir. Network issues.
Can you write down your question?
Okay, sir. I will you please discuss with your other.
No, please write down your question. It's your voice not clear.
Sir, now it is audible, sir?
It is audible, but it's not clear.
Okay.
Please
Can
proceed.
I try again, sir? Okay.
Please proceed. I'll let. How much I can understand, I'll reply.
Okay,
Come on.
Okay.
Sir.
No, Swain, Mr. Bale, finish your question one more time. Let me Bimalendu,
Yes, sir. Yes, sir.
what's your question?
Sir, sir, can I decide that Q is negative so that capital Q and that for Q they are opposing. Let's suppose we are deciding a force on one, that is Q.
Uh,
So that will be in a leftward direction.
uh,
Then Q is negative so that it will be attract. Then also it will be balance only.
there is a force
That
on
is
this. The force on this.
and that
They'll cancel out here.
but that condition also should be satisfied, that
Which can
capital Q and that force on 1 and 3 will be also balanced.
1 and 3 will be also balanced.
That will be only case when small q is negative.
Yes.
Thank you.
You are very fast and very accurate with your answers. Keep it up. Solve more number of questions from the ES, previous gate and ES.
Sir, yes, conventional.
Conventional and prelims also. This is a appeal for all. There are good question. Electrostatics, magnetostatics questions are there in the ESC prelims. If you want to solve more questions, collect the questions from there.
Actually,
Yes, you want to say yes, Bilen.
sir,
Yeah.
I joined in the late batch, so less time to complete other syllabus, so it is actually.
See, I'm not expecting minimum here 4 marks are expected. So give
Yes.
from time. Plan yourself well.
So, yes, sir. So that I mean, in the class only itself, I am deciding more number of questions.
Here we are interested. Yes, how much I can do in the classroom, that I'll do.
Okay.
Okay, fine.
Thank you. Thank you.
Okay. Shivaji.
Sir, good evening, sir.
Yes.
Sir, in the same slide, why we need to place a small q in between like q and capital Q and 4q, sir?
To bring the system into the equilibrium. That
Okay,
is what.
sir. Suppose if small q is placed outside the system, what will happen, sir? Like how can we decide whether the system is in equilibrium or something else?
See here. There are two charges here, Q and 4Q. If it is placed outside, what happens? Let us say if it is a negatively charged one. There will be a force on this one and there will be a force of this one. They will going to add up. There is no question of cancellation.
Okay, sir.
For the cancellation to happen, that means the net force on any charge is what? Net force system is 0. For that, charge must be between them.
Okay, sir. Sir, and then one more thing, how you decided the sign of the small q charge?
Because the force from here, should go here like this. The force from here should go here like this, and they should meet. That happens only when it is a negative charge, because it is mentioned that these two are positive charges.
Okay, so that the net force experienced by small q is 0.
0. That is what the meaning of equilibrium is.
Okay, sir. Sir, and then if what about F21, sir? Will it exist there?
F21 and F12 are both are same. We are interested only in the magnitudes here.
Okay. Okay, sir. That's it. Thank you, sir.
Shivaji done. Kushal ji. Kushal.
Yes, sir. Hello, sir. The phi angle the phi angle should be 2 pi m, sir. For 0 to pi, it should cover only hemisphere.
To 5.
Phi angle of sphere, sir. Yeah, no, theta, sir, theta.
Theta is from 0 to?
So theta is from 0 to pi. So it will only cover hemisphere.
No. Theta is.
Yes, sir.
0 here, 90 here, 180 here. This is 5. Theta is covering entire sphere. Theta like this, 0 to 180. Is it a sphere or hemisphere? 0 here.
From
90.
both sides. You are saying from both sides.
All the sides, not only 2 sides.
It is rotating only one half side from both sides. No?
All sides. 0 to 180. 0 to 180. 0 to 180.
Okay. And sir, in the 77 or 78 slide, the electrostatic and magnostatic, I didn't get it.
This one,
Yes, sir.
just I am saying that if the charge is at rest around this one, there is an electric field. If charge is moving, there is a magnetic field. If the charge is accelerated, the both electric and magnetic field, there is a EM phenomena. So in the next lecture, what we are going to study, that I have explained like a rough idea I have given.
Sir, here you say EM means electromagnetic, na, sir?
Yes, electromagnetic phenomena.
Okay, sir. In the second, that is magnostatic. It is the electromagnetic effect, the magnetic field, na, sir. In the second one, it is magnetic field.
Yes, magnetic field.
We call it as a magnostatic.
Yes.
The current is flowing DC or AC, sir, in this.
First,
second one, current is flowing DC, na?
It just have given some idea, brother. You may be having some difficulty in understanding. This is what I want to say is, if the charge is at rest, there is electric field. If charge is moving, magnetic field. If charge is accelerated, both electric and magnetic fields.
Okay.
How this happens, that we're going to study.
Okay. Yes, sir. In the second option, you have written that no EM phenomena.
I want to have a details. We have started with this one. Let me finish this one. We'll come to this one later.
Okay, sir.
So understood, that is enough. We're going to have a detailed explanation.
So that's why I'm asking the EM phenomena. No, so there is exists a magnetic field.
Okay.
That's what.
Any more questions? Okay. Any more questions? Okay, then I'm going to close the session. Bye, friends. Have a nice day. Good night. Bye, friends.